Okay, section 9.3, scalar product. So first of all, before we talk about scalar product, we need to introduce the idea about define an angle between two vectors. So if you've got two vectors, vector OA and OB, so an angle between OA and OB is going to be angle AOB. So this angle, we'll call this angle theta. Okay, so that's it. What you need to be make sure that those arrows go away from the point. You cannot have one arrow going that way and one going that way and talking that is your theta. That is not correct. You could have the arrows going into the line, into the point, as long as they go in the same direction. So that's fine. So you need to be clear this is what you're dealing with. So this is our angle between two vectors. So the directions need to be either coming away as rays of sunshine or going into the point. Now, here's a definition of a scalar product. So a scalar product of two vectors, we write it as A dot B. We call it A dot B as well. It's called a scalar product. It's simply the two lengths of both vectors multiplied together and times by cos of the angle between them. So this is something you need to memorize. I actually know this, and more often you're going to be using this in the rearranged form. So cos theta is the dot product over the length of two vectors, product of the lengths of two vectors. Okay, now there's two cases which are really important and help you with lots of applications. So on the special occasion where cos theta is equal to 0, so if you think about this definition, if you make cos theta equal to 0, you'll get A dot B is equal to 0. But this is equal to 0 when theta is equal to 90 degrees. So that means A must be perpendicular to B, which is just perfect. So in the situation where the two vectors are perpendicular, then you know that A dot B needs to be equal to 0, and then cos theta is equal to 0. Now, if cos theta is equal to 1, then you're going to have A dot B is equal to A multiplied by B, so the product of the lengths. Again, I prefer to remember this as A dot B over the length of two vectors is equal to 1, because your cos theta is equal to 1. And when does it happen? Well, it happens where theta is equal to 0. So what does it mean? It means that either A is equal to B, so it's the same vector, or it's just parallel to each other. Okay, so the two vectors that are parallel to each other, you will have the situation where the scalar product is equal to the product of its lengths. Okay, let's have a go at example 11. Actually, let's just go quickly back to example 10, because I've not done it. So in the example 10, you've got a diagram, so let me just copy this quickly. The diagram has vector B and vector A. So this angle here is 20 degrees, and you are I think I've talked about it. The actual original question had the two vectors drawn like this. There you go. That's what we had. So, and they've told us that this angle here is 20 degrees, which I withdrawn it. But the question is, what is the angle between A and B? So the angle is not going to be 20. So the point we are making here, that you need to slide that B across, extend it. So you've got two vectors coming away. There you go. So here we shifted this over there, and the actual angle is 160. So angle between A and B is 160 degrees, not 20 degrees. Okay, so just a little example. Okay, let's go on to example 11. We have to find the dot product between the two unit vectors I and j. So over here, what we've got, so I is the unit vector along the x-axis, j is a unit vector along the y-axis. So your I is the modulus of I is 1 and modulus of j is 1. Now x and y axes are perpendicular, so I know that cos theta is equal to 0. So I dot j, using our definition, is going to be 1 multiplied by 1 multiplied by cos 90, which is going to be 0. Not allowed enough room there. Okay, let's have a look at k times k. So again, modulus of k is equal to 1. So here we are going to use the dot product definition. So it's 1 times cos, well, k is 0, angle 0, it's parallel to each other, what's the same. So cos theta is equal to, cos theta will be equal to 1. So k times k, dot product between k, is going to be equal to 1. Okay, and then example C. So over here we've got 4j, so the modulus of 4j is 4 because that's length 4. Modulus of k is 1, cos 90 degrees, plus here we've got 3 is the modulus of 3i, 3 is modulus of 3i, and here we've got cos 0. So 4 times 0 is 0 because cos 90 is 0, and plus 3 times 1, which is 9. So the answer is 9. Okay, we've got example 12. So in this example, we are going to actually look at a general result which will lead to a shorter, well, for you to be able to work out dot product a lot quicker than the previous examples showed. Okay, so what we're going to do, we are actually going to do the multiplying. So we are going to have A dot B, and let's write it out as in the long way in terms of I, j, and k notation. So A1i plus A2j plus A3k, and then B1i add B2j add B3k. We're going to consider all the products. Okay, so here I could have left it in the column vectors as well, but then rewrite it in terms of ij k notation, because you need to consider a1 times b1, a1 times b2, a1 times b3. So let's just deal with this way though. So here we've got a1i dotted together with b1i, then we've got a1i dotted together with b2j, then we've got a1i dotted together with b3k, and then we carry on like this. Okay, so I finished doing the multiplying over here, and also from example 11, if you remember, if the two vectors, so ij and jk, were perpendicular, you worked it out for the dot product to be 0. K and k multiplied together, that gives you 1. So following this, ik will be 0, ii will be 0, and j is going to be 1 as well. So let's have a look at working it out. So remember, if you've got I, that will give you 1, that will give you 0, ik, that's going to be 0, that is going to give you 0. This one here will give you ij dot j, which is 1, so we'll use that result. This one is going to be 0, this one is going to be 0, this one is going to be, I made a mistake here, that was k here, good job, I spotted it. So this one will give me 0, but this one here is going to be, we're going to use k dot k is equal to 1. So effectively this will go, this will go, there you go. So you'll be left with a1 b1, because I dot I will end up with being equal to 1, a2 b2, and a3 b3, which is proven. Now this has a special name. This is called dot product or scalar product, as you know from before. And this is how to obtain the value of that product if you don't know the angle between two vectors, just the position vectors, just the two vectors, sorry, if it's the 2 points, the position vectors of those 2 points, and just two vectors, you don't know the angle between them. So it's going to be a1 b1, so you multiply the x component or x coordinate, if it's, think about it, coordinate of the 2 points, b2 a2 b2 a3 b3. So general result for the dot product. Okay, so we're going to have a look at example 13. You've got two vectors, so we've got, let's write it like this, 8 minus 5 minus 4. Let's dot it together with 5, 4 minus 1. Multiply the x component, so it's 8 times 5 plus minus 5 times 4 plus minus 4 times minus 1. So that's going to be 40 minus 20, so it's 20 plus 4, 24. Now, using this result, we'll be able, and the definition of the dot product, we can find the angle theta. So I always use the rearranged form. Cos theta is a dot b over the length of a multiplied the length of b. So that gives you a dot b is 24. Now a dot b, sorry, the modulus of a is simply your 3D Pythagoras. 8 squared plus 5 squared plus 4 squared. You only need to take the positive values because you're considering lengths. 5 squared, add 4 squared, add 1 squared. So that is 24 over square root of 105 times square root of 42. So theta is equal to cos inverse of that value, which gives me 68.8 degrees to 1 decimal place. Moving on to example 14. So you've got two vectors and we need to find the angle between the two vectors. Now, just put it straight away into the cos theta. Always quote the formula. So a dot b over modulus of a multiplied by modulus of b. So I like to write it like this first. And over here we're going to have 1 squared, add 1 squared, add 3 squared, multiplied by 7 squared, add 2 squared, add 2 squared. So minus 1 times 7. Always write this down though. You can do lots of those calculations in your head, but it's better to write it down. So 1 times minus 2, add 3 times 2, over, this here is going to be square root of 11. This one here is going to be 57, 49, add 8. Okay, so this minus 9 add 6 is minus 3. So theta is equal to arc cos or cos inverse of that value, which gives us an angle of 96.9 degrees, obtuse angle, because cos is negative. Okay, let's move on to example 15. We've got two vectors, a and b, but one of the components, so the y component of vector b is missing, which is replaced with lambda. And we know that these two vectors are perpendicular. We need to find lambda. So if the two vectors are perpendicular, then we know that their dot product must be equal to 0. You've got it has to be an automatic response to those kind of questions. So we're going to work out the dot product by multiplying the I, j, and k components and making the result equal to 0. So it's 2 times 5, add negative 6 times 2, add 1 times lambda, that's equal to 0. So it's 10 minus 12, so it's minus 2, so lambda is equal to 2. Example 16. We have to find a vector, given that a and b are non-parallel vectors. We need to find another vector that is going to be perpendicular to both of these vectors. So we've got to name, so let our vector, the required vector, be A, B, C. Oh, it's a bit annoying because we already have A, B, C. Yeah, okay, let's change it. It's Q, R, S. There you go. So we are going to, if that's the case, then A dotted with Q, R, S needs to be equal to 0, and B dotted with Q, R, S is equal to 0 as well. So let's go ahead and do some calculating. Okay, so let's do A dot QRS. So A is minus 2, 5 minus 4, QRS, that gives me minus 2Q, add 5R, minus 4S, that's equal to 0. Let's do the second one. So that's our vector B, which is 4 minus 8, 5, dotted together with QRS. That's equal to 0. So that gives me 4Q minus 8R plus 5S is equal to 0. Now, in this question, you've got two equations with 3 unknowns. There's no other equation that I can work out. Well, because you actually can have loads of vectors that are perpendicular to the two vectors. They should be just parallel to each other. So what we're going to do, we are going to choose a value for, let's say, fix s. So let s be equal to 1. Okay, and then we've got minus 2q plus 5r minus 4 is equal to 0, and then 4q minus 8r plus 5 is equal to 0. We're going to solve them simultaneously, so let's double this one. So that's going to give me minus 4q plus 10r minus 8 is equal to 0. That one. Okay, so adding them together to eliminate q, I'll have 2r minus 3 is equal to 0. That gives me r is equal to 3 over 2. And then let's find q. So let's choose this one. 4q minus 8 times 3 over 2 plus 5 is equal to 0. So 4q, that's going to give me minus 12 plus 5. So it's 12 minus 5 when you move it across. So that's going to be equal to 7. So q is equal to 7 over 4. So one of the vectors, so perpendicular vector, can be q is 7 over 4, r is 3 over 2, and s is 1. If you wanted whole numbers, you could times everything by 4 and have 7, 6, and 4. There's another possibility. And you can multiply it by anything you like and find another vector that works in this situation. There you go. So you didn't have to choose s to be equal to 1. So one of those components, you choose it to be 1. You could choose it to be equal to something else. And then you solve the other remaining equations simultaneously. And this is how you approach this question. Let's look at example 17. So here we've got 3 points, and we've got to find vectors a, b, and ac, and then area of the triangle ABC. So this is my A, B, C. So AB, AC, and there's another side. Vector OA, so position vector of A is 2, minus 1, 1. This is 5, 1, 7. And this is 6, minus 3, 1. So you can really quickly visually see that AB is end minus beginning. So it's 5 minus 2. So it's 3, 1 take away negative 1. So they are 2 apart. 7 take away 1, 6. You must have taken a step of 6 to get to B. So how many do you need to get from A to B to arrive at from A to C to arrive at C? So how many steps? Well, here from 2 to 6, that's 4. From minus 1 to minus 3, you must have stepped back 2. From 1 to 1, you do 0. Or do end minus beginning, which should give you the same. 6 take away 2, minus 3 take away minus 1, 1 take away 1. There you go. So these are our 2 vectors. So what about the area? Well, I've just found 2 vectors. So if I can find the angle between those 2 vectors, then I'm going to do half of AB sine C. So half of AB multiplied by AC and times our sine of the angle theta. So let's find angle theta. So we need theta. So we use cos theta is equal to dot product of A and B, AB, and AC, and over the length of AB and AC. So the dot product here is going to be 3 to 6 dotted together with 4 minus 2, 0. And the length is 3 squared, add 2 squared, add 6 squared. So the two vectors on the top, 3D Pythagoras. 4 squared, add 2 squared, add 0 squared. So it's 12. So 3 times 4 minus 2 times 2 plus 0. And here we're going to have 49, square root of 49, and square root of 20. Hope that's right. So it's 12 minus 4, that's 8, over 7, and this is going to be 2 root 5, 14 root 5. So theta is equal to cos inverse of 8, you could have cancelled that down, over 14 root 5. If they ask you for the area to be exact, I'll show you on the next, before we move on to exercise 9, see how to do it. If they haven't, then you can use it and run a calculator to work it out. So it's 75.2 degrees, but don't round, because you're going to substitute it into this formula. So now let's put it together. So it's going to be, the area is going to be a half. AB was this length here, so it was 7. AC was 2 root 5, and then sine of the angle 75 point whatever it was. Like I said, you should have it still on the calculator. The answer, when you pop it into the calculator, should be 15.13 to 2 decimal places. Okay, now how would you do it if you were asked to find this area in exact form? And this is really important. The book doesn't deal with it in this example, so I will address it now. So what you've found so far, that the area is going to be a half times 7 times 2 root 5, and then times sine theta. But you found that cos theta from the previous part was 8 over 14 root 5. So let's cancel it down, 4 over 7 root 5. So what it means that we've got to find, we're going to assume theta is an acute angle because it's positive, but it could be, well, for triangle it can only be acute in this situation, otherwise it's bigger than 270, so that's no good anyway. So we've got to find what sine theta is. So what you can do is you can do the normal thing you do in mechanics. So you're going to rewrite it as, this is my theta, this is 4, and this is 7 root 5. So we need to find that side. So this is going to be 7 root 5 squared minus 4 squared, square rooted. So this is going to be 49 times 5 minus 16. So that's what's 49 times half of 490, which is 245, minus 16, so that's 229. Is that right? 35 minus 5, that's correct. So from the same triangle, sine theta must be equal to opposite over hypotenuse. And then you pop it into this result. So it's 2, and that will come, so it's 7 root 5 multiplied by 229 over 7 root 5. So that gives me square root of 229. And remember the answer before, we had 15.13, so you can check on the calculator if indeed it's the same answer. Okay, so go on to exercise 9C.